Inside your skull, 86 billion neurons are firing, each one a storm of electrical signals, each thought a chain of cause and effect. But what if this isn't the full story? What if your brain isn't a machine at all, but a quantum instrument, processing possibilities, collapsing wave functions, connecting you directly to the fabric of reality itself? Every decision, every emotion, every flash of insight, not just chemistry, but quantum computation. The smallest patterns of your mind might mirror the deepest structure of the cosmos. If neurons behave like qubits, then your consciousness isn't bound by biology. It's entangled with the universe. You're looking at the most sophisticated machine in the known universe. 3 pounds of tissue, folded and creased like origami made of dreams, sitting quietly in the darkness behind your eyes. Right now, as you read these words, 100 billion neurons are firing in perfect synchrony, passing electrical signals across synapses at speeds that would make supercomputers weep with envy. This is your brain, the command center of your existence, the author of every thought you've ever had, the silent witness to every moment of your life. For over a century, we have marveled at its mechanical precision. We've mapped its circuits, traced its pathways, and reduced its mysteries to the language of computation. Input, processing, output, stimulus, response, behavior. Action potential, neurotransmitter, synapse. The story we tell ourselves is elegant in its simplicity. The brain is a biological computer. Consciousness is its software, and thoughts are merely the result of neurons firing in predetermined patterns. When you remember your first kiss, specific neural networks activate. When you feel sadness, particular brain regions light up on our scanners. When you make a decision, we can predict your choice milliseconds before you're even aware of making it. But there's something unsettling about this clockwork portrait of the mind, something that doesn't quite fit. Watch a master pianist's fingers dance across the keys, translating emotion into music with impossible precision. Observe a mathematician suddenly grasping a proof that has eluded them for months, the solution arriving not through methodical calculation, but in a flash of insight that seems to come from nowhere. Witness a parent's instantaneous recognition of their child's cry among hundreds of others, a recognition that happens faster than any computer could process. These moments hint at something beyond the mechanical, something that transcends the simple firing of neurons and the release of chemicals. They suggest that consciousness might be more than just the sum of its biological parts. The great neuroscientist Francis Crick, co-discoverer of DNA structure, spent his later years trying to crack the code of consciousness. He believed that if we could just map enough neural circuits, trace enough connections, we would eventually explain the mystery of subjective experience. But even Crick admitted that something fundamental was missing from our understanding. The astonishing hypothesis, is that you, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will, are in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. Yet the more we learn about the brain, the more mysterious it becomes. We can stimulate specific regions and trigger memories, emotions, even out-of-body experiences. We can measure the neural correlates of consciousness with exquisite precision. But correlation is not causation, and mapping is not understanding. We have created the most detailed atlas ever made of the brain's geography, but we still cannot explain why there is something it is like to be you. The mechanical metaphor begins to break down when we confront what philosophers call the hard problem of consciousness. Not just how the brain processes information, but why there is any subjective experience at all. Why should the firing of neurons give rise to the felt experience of seeing red, tasting chocolate, or feeling the warmth of the sunlight on your skin? Why should there be an inner life, a private theatre of consciousness where your experiences play out? A computer can process visual information about redness, wavelength, intensity, saturation, but it doesn't experience the redness of red. It can analyze the molecular structure of chocolate, but it doesn't taste sweetness. It can measure temperature, but it doesn't feel warmth. There is a qualitative dimension to consciousness that seems to slip through the fingers of any purely mechanical explanation. As we peer deeper into the brain's architecture, past the familiar landscape of neurons and synapses, we begin to encounter structures that challenge our comfortable assumptions about biological machinery. Inside each neuron we find a hidden world of extraordinary complexity, a universe in miniature where the rules of classical physics begin to blur and quantum mechanics takes the stage. The camera begins to zoom in, past the cell body, past the nucleus, down to the cytoskeleton, the neuron's internal scaffolding. Here, in these microscopic protein highways, something remarkable may be happening. Something that could revolutionize our understanding of consciousness itself. The clockwork brain, with its neat categories and mechanical certainties, may be nothing more than an illusion, a comforting story we tell ourselves while the real magic happens in the quantum realm hidden within our cells. The image of mechanical neurons begins to shimmer and dissolve, revealing something far more mysterious beneath. A glittering network of quantum possibilities that extends like gossamer threads through the darkness of the skull, connecting not just to other neurons, but perhaps to the very fabric of space and time itself. What is it like to be you? This question, posed by a philosopher Thomas Nagel in his famous thought experiment about bat consciousness, cuts to the heart of the deepest mystery in science. Not how consciousness works, we're making progress there, but why consciousness exists at all. Why should there be something it feels like to experience the world rather than nothing? Right now, you are having an experience, not just processing information about these words, but actually experiencing the sensation of reading them. There is something it is like to be you in this moment. The particular quality of your awareness, the subjective texture of your thoughts, the private world of your inner life that no one else can access. This is what philosophers call qualia, the felt quality of conscious experience that seems impossible to reduce to mere neural computation. We have made extraordinary progress in mapping the neural correlates of consciousness. We know that when you see the color blue, specific wavelengths of light activate particular cells in your retina, which send signals through your optic nerve to visual processing areas in your cortex. We can trace this entire pathway with remarkable precision, but nowhere in this chain of neural events do we find the actual experience of blueness, that subjective, qualitative sensation that makes blue feel like blue rather than red or green. This is what the philosopher David Chalmers calls the hard problem of consciousness. The easy problems of the consciousness. How the brain processes information, integrates sensory inputs, controls behavior, are yielding to scientific investigation. But the hard problem, why there is subjective experience at all, remains as mysterious as ever. Consider the puzzle of pain. We understand the neurophysiology of nociception quite well. Specialized nerve fibers detect tissue damage and transmit signals to the cerebrospinal cord and brain, which process this information and generate appropriate responses. But why should this neural activity be accompanied by the awful, unmistakable sensation of pain? Why not just unconscious damage detection and avoidance behavior? What evolutionary purpose does the subjective feeling serve? The mystery deepens when we consider the unity of consciousness. Right now, you're experiencing a single, unified field of awareness that seamlessly integrates vision, hearing, touch, thought, emotion, and memory into a coherent whole. Yet this integration is happening across billions of neurons distributed throughout your brain, with no central location where it all comes together. There is no Cartesian theatre where all the information is presented to a watching self. Instead, consciousness seems to emerge from the collective activity of neural networks, yet somehow transcends them. Nobel laureate Roger Penrose, one of the world's most distinguished physicists, has argued that consciousness cannot be explained by conventional neuroscience because it exhibits properties that classical physics cannot account for. He points to Gödel's incompleteness theorems, which show that mathematical truth cannot be reduced to algorithmic computation, as evidence that human understanding transcends anything a classical computer or classical brain could achieve. I think consciousness is a phenomenon that is not computable, Penrose declares. It's not something that can be simulated by a computer, no matter how complicated. If consciousness were purely classical, he argues, then a sufficiently advanced computer should be able to simulate it perfectly. But consciousness seems to involve non-algorithmic processes that no classical system can replicate. This brings us to one of the most startling possibilities in modern science, that consciousness might require quantum mechanics to explain. Quantum mechanics, the physics of the very small, describes a reality that is fundamentally different from our everyday experience. At the quantum level, particles can exist in multiple states simultaneously, instantaneously influence each other across vast distances, and behave in ways that seem to violate our intuitive understanding of cause and effect. For decades, most scientists assumed that quantum effects were irrelevant to brain function. The brain, they argued, is too warm, too wet, and too noisy for delicate quantum phenomena to survive. Quantum coherence, the ability of quantum systems to maintain their strange properties, was thought to be destroyed almost instantly by the brain's biological environment. But what if this assumption is wrong? What if evolution has found ways to harness quantum mechanics for the most sophisticated information processing task in the universe, the generation of conscious experience? Recent discoveries in quantum biology have revealed that nature uses quantum effects far more extensively than anyone imagined. Photosynthesis, the process that powers most life on Earth, relies on quantum coherence to achieve nearly perfect energy transfer efficiency. Birds navigate using quantum entanglement in their retinas. Even the sense of smell may depend on quantum tunneling effects. If evolution has harnessed quantum mechanics for these functions, why not for consciousness? Perhaps the reason we've struggled to explain consciousness using classical physics is that consciousness is fundamentally quantum. Perhaps the mysterious properties of awareness, its unity, its irreducibility, its capacity for creative insight, reflect the strange properties of quantum mechanics itself. This possibility opens up a radically different way of thinking about the mind. Instead of consciousness emerging from the classical firing of neurons, it might arise from quantum processes occurring within and between brain cells. Instead of being a mere epiphenomenon of neural computation, consciousness might be a fundamental feature of quantum reality itself. The implications are staggering. If consciousness is quantum, then the boundary between mind and universe becomes blurred. Quantum mechanics tells us that the act of observation plays a fundamental role in shaping reality, that the universe is not just passively observed, but actively influenced by conscious awareness. This suggests a profound connection between mind and cosmos that classical physics could never accommodate. The camera slowly zooms in on a single neuron, its membrane shimmering with electrical activity. But as we move closer, past the surface into the cell's interior, we begin to see something unexpected. A delicate lattice of protein filaments that pulse with their own mysterious rhythm, as if responding to forces beyond the reach of classical physics. Deep within each neuron, hidden from the casual observer, lies a structure of extraordinary beauty and complexity. Imagine descending through the neuron's cell membrane like Alice falling down the rabbit hole, shrinking past the familiar landscape of organelles and proteins until you encounter something that looks like a cosmic highway system. Hollow tubes made of protein that extend throughout the cell like the skeleton of some magnificent cathedral. These are microtubules, and they may hold the key to consciousness itself. For most of neuroscience's history, microtubules were considered mere cellular scaffolding, the cytoskeleton that gives neurons their shape and provides tracks for molecular transport. They were the brain's infrastructure, important but unremarkable, like the steel beams inside a skyscraper that no one thinks about once the building is complete. But Stuart Hameroff, an anesthesiologist at the University of Arizona, saw something different when he looked at these structures. To his trained eye, microtubules didn't look like passive scaffolding at all. They looked like the most sophisticated information processing system in biology. Each microtubule is composed of protein subunits called tubulins, arranged in a precise helical pattern that extends for micrometers through the cell. These tubulins can exist in different conformational states, different shapes that represent different bits of information, like biological switches that can be turned on or off. But unlike the switches in a computer, tubulins can exist in quantum superposition, holding multiple states simultaneously until something forces them to choose. Hameroff realized that a single microtubule could potentially store and process more information than the entire internet. With billions of tubulin subunits per microtubule, and millions of microtubules per neuron, and billions of neurons per brain, the computational capacity of this quantum information processing system would be almost incomprehensibly vast. But storage capacity alone doesn't explain consciousness. What makes microtubules truly remarkable is their potential for quantum coherence, the ability to maintain quantum superposition and entanglement across macroscopic scales. In the Hameroff joined forces with Roger Penrose to develop a theory they called orchestrated objective reduction, or ORCH-OR. According to their theory, consciousness arises when quantum information processing in microtubules reaches a critical threshold. Imagine quantum superposition as a delicate balancing act, with tubulins existing in multiple states simultaneously, creating vast networks of quantum possibilities that extend throughout the brain. These quantum states influence each other through entanglement, creating a unified field of information that transcends classical neural networks. When this quantum orchestration reaches a critical mass, when enough tubulins become entangled in a coherent pattern, something extraordinary happens. The superposition collapses in what Penrose calls objective reduction, and a moment of consciousness emerges. This collapse is not random, but influenced by the fundamental geometry of space-time itself, connecting the mind to the deepest structures of reality. The theory suggests that each moment of consciousness corresponds to a quantum collapse event in the brain's microtubule networks. These events occur perhaps 40 times per second, creating the stream of consciousness as a series of discrete quantum moments, like frames in a cosmic movie of awareness. This would explain many puzzling features of consciousness that classical neuroscience struggles with. The unity of conscious experience could arise from quantum entanglement linking tubulins across different brain regions into a single coherent state. The irreducible nature of qualia could reflect the fact that quantum information cannot be copied or divided without being destroyed. The speed of intuitive insights could result from quantum computation that processes information in parallel across multiple dimensions simultaneously. Recent experimental evidence has begun to support the idea that microtubules are far more than passive cellular scaffolding. Sophisticated imaging techniques have revealed that microtubules in living neurons exhibit rhythmic patterns of assembly and disassembly that seem to correlate with neural activity. When anesthetics like propofol cause unconsciousness, they bind directly to microtubules, suggesting that these structures play a crucial role in maintaining awareness. Perhaps most remarkably, researchers have discovered that microtubules can maintain quantum coherence even in the warm, wet environment of living cells. This coherence appears to be protected by the microtubule's unique structure and dynamics, which may have evolved specifically to preserve quantum information. The implications extend far beyond neuroscience. If consciousness arises from quantum processes in microtubules, then every neuron is a quantum computer of extraordinary sophistication. The brain becomes not just a biological organ, but a quantum information processing system that operates according to the deepest laws of physics. This perspective transforms our understanding of mental phenomena. Creativity and insight might result from quantum computation exploring vast solution spaces simultaneously. Memory could involve quantum entanglement between past and present states of microtubules. Dreams might represent the brain's quantum networks exploring alternative realities unconstrained by sensory input. The boundary between brain and cosmos begins to blur when we consider that microtubules may be sensitive to quantum fields that permeate all of space. Some researchers speculate that consciousness could involve interaction with the quantum vacuum itself, the seething sea of virtual particles that underlies all of reality. If true, then our thoughts and experiences might be connected to the fundamental information structure of the universe. Standing at the entrance to this quantum realm, we begin to glimpse consciousness not as an emergent property of classical neural networks, but as a fundamental feature of reality itself, a universe becoming aware of itself through the quantum orchestration of biological structures that evolution has crafted over billions of years. The camera continues its descent into the microtubule's hollow core, revealing the dancing tubulins in their quantum superposition, sometimes here, sometimes there, sometimes everywhere at once. The visualization becomes increasingly abstract as classical notions of space and time begin to break down, revealing patterns that seem to connect these tiny structures to the cosmic web of galaxies themselves. Something is wrong with our timing. Consider Maria Sharapova at the 2004 Wimbledon final, facing 120 m per serve from Serena Williams. The ball leaves Williams' racket and begins its journey across the net. In classical neuroscience terms, here's what should happen. Light reflecting off the ball hits Sharapova's retina, triggering electrical signals that travel through her optic nerve at about 120 meters per second, fast by human standards, but glacial compared to the speed of the approaching ball. These signals reach her visual cortex, where millions of neurons begin the laborious process of analysing the ball's trajectory, speed, and spin. This information must then be integrated with proprioceptive feedback about her body position, memories of a similar ball, similar serves, strategic calculations about court position, and motor commands to coordinate the complex biomechanics of a tennis return. According to classical neural processing speeds, this entire sequence should take several hundred milliseconds, far too long to return a serve that will reach her in less than half a second. Yet Sharapova not only returns the serve, but does so with pinpoint precision, sending the ball exactly where she intends it to go. How is this possible? This is what researchers call the speed problem, the mysterious gap between the brain's apparent processing limitations and its actual performance in real-time situations. It manifests everywhere we look in human cognition. A jazz musician improvising at a breakneck tempo makes split-second decisions about harmony, rhythm and melody that should require extensive conscious deliberation, yet the music flows as if the notes are choosing themselves. A surgeon making a life or death decision during a complex operation integrates vast amounts of sensory information, medical knowledge, and motor control in timeframes that seem to defy the speed limits of neural computation. Perhaps most mysteriously, consider those moments of sudden insight that scientists and mathematicians describe, the eureka experiences where solutions to complex problems appear instantaneously, fully formed, as if downloaded from some external source. These breakthroughs often occur not during focused concentration, but during relaxed states, while walking, showering, or on the edge of sleep, when classical neural processing should be at its slowest. Henri Poincaré, the great French mathematician, described one such moment with striking clarity. At the moment when I put my foot on the step, the idea came to me, without anything in my former thoughts seeming to have paved the way for it, that the transformations I had used to define the Fuchsian functions were identical with those of non-Euclidean geometry. The solution to a problem that had eluded him for months arrived in an instant, complete and certain. Traditional neuroscience attempts to explain these phenomena through concepts like unconscious processing and parallel computation. The idea is that the brain works on problems in the background, below the threshold of awareness, and then presents the finished solution to consciousness. But this explanation raises more questions than it answers. How does unconscious processing achieve speeds that conscious processing cannot? What mechanism allows the brain to explore vast solution spaces simultaneously? Recent research has revealed that these moments of rapid cognition often correlate with the unusual patterns of brain activity that don't fit classical models of neural processing. During insight experiences, researchers observe sudden bursts of high-frequency gamma waves, oscillations at 3100 Hz, that seem to synchronize activity across distant brain regions in ways that should be impossible given the speed of neural transmission. Even more puzzling, these gamma bursts often appear to precede the conscious recognition of insight by several hundred milliseconds, suggesting that solutions are somehow available to the brain before they become available to awareness. It's as if the answer exists in some preconscious realm and then suddenly materializes in conscious experience. The speed problem becomes even more acute when we consider the phenomenon of intuitive decision-making. Studies have shown that people can make accurate judgments about complex situations, the outcome of elections, the trustworthiness of strangers, the quality of investment, opportunities within milliseconds of exposure, often with accuracy that rivals or exceeds careful analytical reasoning. This suggests that the brain has access to rapid pattern recognition and information processing capabilities that operate on entirely different principles from the step-by-step neural computation described in textbooks. It's as if consciousness can sometimes bypass the normal speed limits of biological information processing and access answers through some alternate channel. Quantum mechanics offers a tantalizing possibility for explaining these phenomena. Quantum computation operates on fundamentally different principles from classical computation. While a classical computer processes information sequentially, one bit at a time, a quantum computer can explore multiple solution paths simultaneously through superposition and entanglement. If consciousness involves quantum processes in microtubules, as Penrose and Hameroff suggest, then the brain might be capable of quantum computation that transcends classical speed limits. Quantum superposition would allow neural systems to explore vast numbers of possibilities simultaneously. while quantum entanglement could enable instantaneous coordination between distant brain regions. This quantum processing might normally operate below the threshold of consciousness, contributing to the brain's background operations without creating explicit awareness. But during moments of insight, creative breakthrough, or intuitive recognition, quantum solutions might suddenly collapse into classical neural states, creating the experience of ideas appearing from nowhere. The implications are profound. If consciousness can access quantum processing capabilities, then human cognition might be fundamentally more powerful than any classical computer could ever be. The speed problem wouldn't be a limitation of biological neural networks, but evidence of a deeper layer of information processing that operates according to quantum mechanical principles. The camera zooms out from individual neurons to show the brain's activity in real time during a moment of sudden insight. Classical neural firing patterns suddenly give way to something else, a shimmering cascade of synchronized activity that seems to move faster than biological signals should travel, as if the brain is briefly operating according to different physical laws entirely. We return to where we began, the darkness behind your eyes, the 3-pound universe that somehow contains all of reality as you know it. But now we see it differently. What appeared to be a biological machine now reveals itself as something far more extraordinary, a quantum information processing system that might be connected to the deepest structures of reality itself. Look up at the night sky and consider the cosmic web, the vast network of dark matter filaments that spans the observable universe, connecting galaxies across billions of light years in an intricate lattice of gravitational influence. Now, look down at the microtubules in your neurons, hollow protein tubes arranged in networks that span the microscopic universe of your brain cells. The resemblance is more than metaphorical. At the largest scales, the universe organizes itself into connected networks that process and transmit information through space and time. Galaxy clusters communicate through gravitational waves and electromagnetic radiation, sharing information about their states across cosmic distances. Stars influence each other through stellar winds and the complex dance of orbital mechanics. Even at the quantum level, particles that have never directly interacted can become entangled, sharing information instantaneously across the universe. Perhaps consciousness represents the universe becoming aware of itself through the same fundamental processes that organize matter and energy at every scale of reality. Perhaps the quantum networks in your brain are not separate from the cosmic networks that structure the universe, but extensions of them, biological implementations of the same information processing principles that govern everything from subatomic particles to galaxy clusters. This perspective transforms our understanding of what it means to be conscious. You are not a passive observer of reality, receiving information about an external world through your senses and processing it in the isolation of your skull. Instead, you are an active participant in the universe's ongoing process of self-organization and self-awareness. Your thoughts and experiences are not produced by your brain. They are the universe thinking and experiencing through your brain. When you have a moment of insight, you are not accessing some private mental resource. You are tapping into the same quantum information processing that underlies all of reality. When you feel the beauty of a sunset or the poignancy of music, you are experiencing the universe's aesthetic appreciation of itself. When you contemplate the mystery of consciousness, you are the cosmos attempting to understand its own nature. This radical reconceptualization helps explain some of the deepest puzzles about consciousness. Why should subjective experience exist at all? Because information processing is a fundamental feature of reality, and consciousness is what information processing feels like from the inside. Why does consciousness seem unified and irreducible? Because it reflects the quantum entanglement that connects all information in the universe into a coherent whole. The implications extend far beyond neuroscience into fundamental questions about the nature of reality itself. If consciousness involves quantum processes that extend beyond the boundaries of individual brains, then the classical division between mind and world, subject and object, observer and observed begins to break down. Quantum mechanics has already suggested that consciousness plays a fundamental role in shaping reality through the measurement problem, the puzzle of why quantum superposition collapses into definite states when observed. Some interpretations of quantum mechanics propose that consciousness itself is what causes wave function collapse, making observers active participants in determining the nature of reality. If consciousness involves quantum processes in the brain that are connected to quantum processes throughout the universe, then every moment of awareness becomes an act of cosmic self-determination. Your thoughts don't just reflect reality, they participate in creating it. Your experiences don't just process information about the universe, they are the universe processing information about itself. This vision might explain the strange effectiveness of mathematics in describing the natural world. Perhaps mathematical insights feel like discoveries rather than inventions because they reflect the deep information structures that consciousness shares with the cosmos. When mathematicians glimpse eternal truths about geometry, number theory, or topology, they might be accessing the same quantum information networks that organize physical reality. It might also explain the universal human sense that consciousness connects us to something larger than ourselves, the feeling that our deepest experiences touch something eternal and cosmic. Rather than being an illusion or projection, this sense might reflect the literal truth that consciousness is the universe's method of self-awareness. Standing at the threshold between classical and quantum descriptions of the mind, we face a choice that will determine not just our understanding of consciousness, but our understanding of our place in the cosmos. We can continue to see ourselves as isolated biological machines, generating the illusion of awareness through the mechanical firing of neurons. Or we can embrace the possibility that we are manifestations of a conscious universe, quantum information processing system that represent the cosmos coming to know itself. The universe in your head is not a metaphor. It is the literal truth about what you are, a localized intensification of the same quantum information processing that structures all of reality. Your consciousness is not produced by your brain. Your consciousness is the universe experiencing itself through your brain. The camera pulls back through the skull, past the brain tissue, past the individual neurons, past the microtubules themselves, until we see the quantum network that connects them. But this network doesn't stop at the boundaries of the brain. It extends outward, through the nervous system, through the body, into the space around us, connecting to other conscious beings, to the quantum fields that permeate all of space, to the cosmic web itself. We realize that we are looking not at a brain, but at a node in the universe's network of self-awareness, a point where the cosmos becomes conscious of its own existence. The journey into the quantum mind has begun, but this is only the first act of a larger story, one that will challenge everything we think we know about consciousness, reality, and our place in the cosmic order. Fade to black as we prepare to descend even deeper into the quantum foundations of consciousness, where the boundaries between mind and universe dissolve entirely, and we discover that the deepest questions about awareness are also the deepest questions about the nature of reality itself. The war for consciousness begins in the fluorescent-lit corridors of academic institutions, where reputations are built and destroyed with the precision of surgical instruments. Here, in conference rooms that smell of coffee and skepticism, the quantum consciousness hypothesis faces its most formidable opponents, scientists whose life's work has been built on the solid foundation of classical physics and computational neuroscience. Dr. Max Tegmark adjusts his glasses and leans forward across the conference table, his voice carrying the weight of mathematical certainty. As a cosmologist at MIT, Tegmark has spent his career mapping the universe's largest structures, but today he's focused on something much smaller, the allegedly quantum processes in the human brain. The decoherence time, he begins, his Swedish accent lending authority to each syllable, is the death knell for any quantum consciousness theory. Behind him, equations fill a whiteboard like an indictment. In the warm, wet, noisy environment of the brain, quantum coherence cannot survive for more than 10^13 seconds. That's less than a trillionth of a second. Neural processes, by contrast, operate on timescales of milliseconds to seconds. The gap is not just significant, it's insurmountable. Tegmark's calculation is devastating in its simplicity. Quantum coherence, the delicate state that allows particles to exist in superposition and maintain entanglement, is notoriously fragile. It requires near-perfect isolation from environmental disturbance. The slightest interaction with the surrounding environment causes the quantum system to decohere, collapsing into classical behavior. The brain, Tegmark argues, is the worst possible environment for maintaining quantum coherence. At body temperature, molecules are in constant thermal motion, colliding billions of times per second. The brain is saturated with ions, Creating an electrical environment that would instantly destroy any quantum superposition is like trying to maintain a delicate crystal structure in the middle of an earthquake. Penrose and Hameroff are chasing a mirage, Tegmark declares. They want to invoke quantum mechanics to explain consciousness, but they ignore the fundamental physics that makes quantum consciousness impossible in biological systems. It's not just unlikely, it's thermodynamically forbidden. Across the scientific community, other distinguished voices join the chorus of skepticism. Christoph Koch, one of the world's leading consciousness researchers, approaches the problem from a different angle. As chief scientist at the Allen Institute for Brain Science, Koch has devoted his career to mapping the neural correlates of consciousness with exquisite precision. We don't need quantum mechanics to explain consciousness, Koch states, with the confidence of someone who has spent decades peering into the brain's electrical activity. Classical neural networks can already account for every aspect of conscious experience we can measure. We can predict, with remarkable accuracy, what someone is seeing, thinking, or feeling based purely on classical neural firing patterns. Koch points to the remarkable success of computational models of consciousness. Modern AI systems, built on classical computation principles, can already perform many tasks once thought to require consciousness, recognizing faces, understanding language, even creating art and music. If consciousness emerges from quantum processes, Koch argues, then why can classical computers replicate so many of its functions? The burden of proof lies with the quantum consciousness advocates, Koch continues. They must demonstrate not just that quantum processes occur in the brain, which no one doubts at some trivial level, but that these processes are necessary for consciousness. So far, they have failed to meet this burden. The philosopher Daniel Dennett, from his position at Tufts University, brings a different kind of skepticism to bear. For Dennett, the entire quantum consciousness debate represents a fundamental misunderstanding of what consciousness actually is. He views it as a classic example of what he calls greedy reductionism, the attempt to explain complex phenomena by appealing to increasingly exotic physical processes. Consciousness doesn't need quantum mechanics any more than digestion needs quantum mechanics, Dennett argues with characteristic bluntness. Yes, quantum effects underlie all chemistry, and chemistry underlies all biology, but that doesn't mean we need quantum mechanics to explain why stomachs digest food, or why brains generate awareness. Dennett sees the appeal to quantum mechanics as a form of scientific mysticism, an attempt to preserve the mystery of consciousness by grounding it in the inherent mystery of quantum mechanics. But consciousness, he argues, isn't actually mysterious once we abandon our intuitive misconceptions about what it means to be aware. The quantum consciousness theorists are solving the wrong problem, Dennett continues. They're trying to explain something that doesn't exist, some magical, irreducible property of consciousness that transcends physical processes. But consciousness is exactly what it appears to be. The brain's real-time monitoring of its own internal states, nothing more, nothing less. The skeptics' arguments are powerful because they rest on solid experimental foundations. Decades of research in quantum decoherence have established precise mathematical relationships between environmental noise and the destruction of quantum coherence. These aren't theoretical speculations, but measured physical constants that can be verified in any laboratory. Moreover, the skeptics can point to the extraordinary success of classical neuroscience in explaining brain function. From the molecular mechanisms of memory formation to the global dynamics of conscious awareness, classical physics and chemistry have provided detailed, testable explanations for virtually every aspect of neural activity. The skeptics also raise troubling questions about the explanatory power of quantum consciousness theories. Even if quantum processes do occur in the brain, what exactly do they explain about consciousness that classical processes cannot? How does quantum superposition in microtubules give rise to the subjective experience of seeing red or feeling pain? The quantum consciousness advocates, critics argue, have simply pushed the mystery of consciousness one level deeper without actually solving it. Dr. Patricia Churchland, a pioneering neurophilosopher, puts the criticism in historical perspective. Every generation of consciousness researchers discovers some new physical phenomenon and declares it the key to understanding awareness, she observes. In the past, it was electromagnetic fields or chaotic dynamics, or quantum mechanics, but consciousness always turns out to be more mundane than these exotic explanations suggest. The scientific establishment's resistance to quantum consciousness theories reflects more than just intellectual conservatism. It represents a hard-won understanding of how science progresses through careful experimentation, rigorous peer review, and the gradual accumulation of evidence. Extraordinary claims require extraordinary evidence, and the quantum consciousness hypothesis, critics argue, has not yet met this standard. As the debate intensifies, the skeptics maintain their position with the confidence of those who have the weight of established science behind them. Quantum mechanics operates in the microscopic realm of atoms and photons. Consciousness operates in the macroscopic realm of neurons and brain networks. The two domains seem separated by an unbridgeable gulf of scale and physics. But even as the skeptics marshal their formidable arguments, something is stirring in laboratories around the world. New experiments are beginning to challenge the comfortable assumptions about quantum decoherence in biological systems. The wall between quantum and classical may not be as impermeable as once believed. The camera slowly pans across the faces of the skeptics, their expressions confident and certain. But in the background, barely audible, we begin to hear a different sound. The hum of quantum experiments in distant laboratories, where researchers are discovering that nature is far more quantum than anyone imagined. In a laboratory at the University of Arizona, Dr. Stuart Hameroff carefully adjusts the microscope that has become his window into a hidden quantum world. The anesthesiologist-turned-consciousness researcher moves with the practiced precision of someone who has spent decades navigating between the operating room and the research lab, between the urgent demands of saving lives and the patient work of unraveling the universe's deepest mysteries. The skeptics make a fundamental error, Hameroff says, his voice carrying the weight of decades spent defending his revolutionary ideas against scientific orthodoxy. They assume that biological systems are passive victims of environmental decoherence. But evolution is smarter than that. Life doesn't just tolerate quantum mechanics, it harnesses it. The evidence supporting this radical claim has been accumulating steadily over the past 2 decades, forcing even the most ardent skeptics to acknowledge that nature uses quantum effects far more extensively than anyone imagined. The revolution began with the discovery of quantum coherence in photosynthesis, the process that powers virtually all life on Earth. In the photosynthetic complexes of green plants and bacteria, researchers discovered that energy transfer operates through quantum superposition, allowing photons to explore multiple pathways simultaneously before collapsing into the most efficient route. This quantum computation occurs at room temperature, in the wet, noisy environment of living cells, exactly the conditions that Tegmark's calculations suggest should destroy quantum coherence instantly. Nature solved the decoherence problem billions of years ago, explains Dr. Matthew Fisher, a quantum physicist at UC Santa Barbara who has proposed his own quantum consciousness mechanism. Biological systems don't fight decoherence, they use it. They've evolved structures that protect quantum coherence just long enough to perform quantum computation, then allow controlled decoherence to extract the computational results. Fisher's research focuses on phosphorus nuclei in neural microtubules, quantum systems with extraordinarily long coherence times that could potentially store and process quantum information in the brain. Unlike the fragile quantum states that Tegmark dismisses, phosphorus nuclear spins can maintain coherence for hours or even days in biological environments. We're not talking about preserving perfect quantum coherence for extended periods, Fisher clarifies. We're talking about exploiting transient quantum effects that occur faster than decoherence can destroy them. Quantum biology operates in the sweet spot between quantum and classical physics. The experimental evidence supporting quantum consciousness theories has grown increasingly sophisticated. In 2014, Anirban Bandyopadhyay at Japan's National Institute for Materials Science published groundbreaking measurements of quantum vibrations in microtubules extracted from rat brains. Using cutting-edge spectroscopy techniques, his team detected coherent oscillations at multiple frequency scales, from megahertz to terahertz ranges. The microtubules are not passive structural elements, Bandyopadhyay explains. His data transformed into hypnotic visualizations of oscillating quantum fields. They are active information processing networks that maintain coherent vibrations across macroscopic distances. We are literally watching quantum computation in biological systems. The implications of these measurements extend far beyond neuroscience. If microtubules can maintain quantum coherence in living brain tissue, then the fundamental assumptions underlying classical neuroscience may need to be reconsidered. The brain may not be a classical computer made of biological components, but a quantum computer that evolution has been perfecting for hundreds of millions of years. Sir Roger Penrose, now in his 90s but still sharp as the mathematical insights that made him famous, defends his orchestrated objective reduction theory with characteristic intellectual fearlessness. The classical neuroscience paradigm has reached its limits, he argues, from his study at Oxford. Surrounded by the mathematical treatises that revolutionized our understanding of black holes and space-time, we can map every neural connection, measure every action potential, simulate every synaptic interaction, and we still won't understand why there is something it is like to be conscious. Classical physics is simply not rich enough to account for the phenomenon of subjective experience. Penrose points to mathematical insights as evidence for non-computational processes in consciousness. When mathematicians discover new theorems, they are not following algorithmic procedures, they are recognizing mathematical truth through insight that transcends any computational process. This suggests that consciousness involves non-algorithmic elements that quantum mechanics can provide, but classical computation cannot. The quantum consciousness defenders also draw support from unexpected quarters. Research on bird navigation has revealed that migratory species use quantum entanglement in specialized proteins in their retinas to detect Earth's magnetic field. These quantum compasses operate in warm, wet biological conditions, maintaining entanglement long enough to provide precise directional information. Even more remarkably, quantum effects appear to play a role in the human sense of smell. Recent studies suggest that olfactory receptors can distinguish between molecules based on quantum tunneling effects, the ability of electrons to pass through energy barriers that should be insurmountable according to classical physics. The nose, it turns out, may be a quantum chemical sensor of extraordinary sensitivity. If evolution has harnessed quantum mechanics for photosynthesis, magnetoreception, and olfaction, why not for consciousness, asks Dr. Luca Turin, a biophysicist whose quantum theory of smell initially faced skepticism but has gained experimental support. Consciousness is the most sophisticated information processing task in biology. It would be strange if it didn't exploit the most powerful information processing principles available. The quantum consciousness advocates also point to the unique properties of anesthetics as supporting evidence. Hameroff's clinical experience with anesthesia has revealed puzzling patterns that classical neuroscience struggles to explain. Anesthetic molecules that cause unconsciousness share no common chemical structure, yet they all bind to the same sites in microtubules, suggesting that consciousness depends on quantum processes that anesthetics disrupt. When I administer propofol to a patient, I'm not just depressing neural activity, Hameroff explains. I'm interfering with quantum coherence in microtubules throughout the brain. The patient doesn't gradually become less conscious. They transition abruptly from awareness to unconsciousness. Yes, consciousness. Like a quantum phase transition. Recent experiments have begun to test these ideas directly. Researchers are using sophisticated quantum measurement techniques to probe the brain's quantum properties during different states of consciousness. Preliminary results suggest that conscious states correlate with specific patterns of quantum coherence that disappear during anesthesia or deep sleep. The defenders acknowledge that their theories remain controversial and incompletely proven, but they argue that the accumulating evidence points toward a fundamental revision of our understanding of consciousness and its relationship to quantum mechanics. We're at a pivotal moment in the history of consciousness research, reflects Hameroff. The classical paradigm has given us detailed maps of neural activity, but it has failed to explain the territory of subjective experience. Quantum consciousness theories offer a bridge between the objective world of physics and the subjective world of awareness. The quantum defenders are not simply proposing that consciousness involves quantum mechanics. They are suggesting that consciousness is quantum mechanics, at least in part. The strange properties of quantum mechanics, superposition, entanglement, non-locality, may not be abstract features of microscopic physics, but the very foundations of conscious experience. The camera moves through Hameroff's laboratory, past the quantum measurement equipment, into a visualization of microtubules pulsing with coherent vibrations. The oscillations seem to synchronize across vast networks, creating patterns that extend far beyond individual cells, suggesting that consciousness might indeed emerge from quantum orchestration on a scale that dwarfs classical neural computation. In the depths of quantum mechanics lies a phenomenon so strange that Einstein himself called it spooky action at a distance, quantum entanglement. When two particles become entangled, they share a mysterious connection that transcends space and time. Measure one particle, and its entangled partner instantaneously knows the result, regardless of the distance separating them. This quantum correlation has been verified across laboratory benches, between cities, even between Earth and satellites orbiting in space. But what if entanglement operates not just between photons and electrons, but between the quantum processes that generate consciousness itself? Dr. Henry Stapp, a quantum physicist at Berkeley, sits in his book-lined office contemplating the implications of quantum mechanics for consciousness. His weathered hands trace equations on a blackboard, while his eyes reflect decades of grappling with the deepest puzzles of quantum theory. Consciousness and quantum entanglement may be two sides of the same phenomenon, Stapp suggests, his voice carrying the careful precision of someone who has spent a lifetime at the intersection of physics and philosophy. When we experience the unity of consciousness, the seamless integration of thoughts, sensations, and emotions into a single coherent awareness, we may be experiencing the subjective side of quantum entanglement. The unity of consciousness has puzzled philosophers and scientists for centuries. How does the brain integrate information from millions of neurons scattered across different regions into a single, unified experience? How do visual inputs from the eyes, auditory signals from the ears, tactile sensations from the skin, and abstract thoughts from the cortex all come together in one coherent stream of awareness? Classical neuroscience proposes various binding mechanisms, neural oscillations, attention networks, global workspace theories, but none fully explains how separate neural events become unified conscious experience. The unity seems to emerge from neural activity but cannot be reduced to it. Quantum entanglement offers a radically different perspective. If consciousness involves quantum processes in microtubules throughout the brain, then entanglement could instantaneously connect these processes into a unified quantum state. The seamless unity of conscious experience would reflect the seamless unity of quantum entanglement. Imagine your consciousness as a quantum field that extends throughout your brain, suggests Dr. Amit Goswami, a quantum physicist who has explored the connections between consciousness and quantum mechanics. Individual thoughts and sensations are excitations in this field, but they remain connected through quantum entanglement. This would explain why consciousness feels unified rather than fragmented. The implications extend far beyond individual consciousness. If quantum entanglement underlies the unity of awareness within a single brain, it might also create connections between different conscious beings. The boundaries between self and other, which seem so solid in our everyday experience, might be more permeable than we imagine. This possibility resonates with ancient philosophical traditions that have long described consciousness as fundamentally interconnected. In Hindu philosophy, the concept of Brahman suggests that individual consciousness is an illusion, that all awareness is ultimately one universal consciousness experiencing itself through countless perspectives. Buddhist teachings on interdependence propose that the self is a convenient fiction, that consciousness arises through the interconnection of all phenomena. Carl Jung, the pioneering psychologist, coined the term synchronicity to describe meaningful coincidences that seem to transcend ordinary cause and effect. He proposed that consciousness might be connected to a collective unconscious, a shared psychological space that could explain why similar ideas and symbols appear independently across different cultures and individuals. Perhaps Jung's synchronicities reflect quantum entanglement between conscious beings, speculates Dr. Dean Radin, a consciousness researcher who has spent decades investigating phenomena that challenge classical scientific paradigms. If consciousness involves quantum processes, then entangled minds might share information in ways that classical physics cannot explain. Recent experiments in quantum mechanics have demonstrated entanglement between increasingly large and complex systems. Researchers have entangled not just individual particles, but entire molecules, crystals, and even biological systems. If quantum entanglement can occur between the microtubules in different neurons within a single brain, it might also occur between the microtubules in different brains. This possibility has inspired a new generation of consciousness researchers to investigate whether human awareness extends beyond the boundaries of individual skulls. Studies of telepathy, remote viewing, and other forms of anomalous cognition have produced intriguing results that some researchers interpret as evidence for quantum connections between minds. While these studies remain controversial and are often dismissed by mainstream science, they point toward questions that quantum consciousness theories make impossible to ignore. If consciousness is fundamentally quantum, then the classical assumption that minds are isolated information processing systems may need to be reconsidered. The quantum entanglement model of consciousness also offers new perspectives on some of the deepest mysteries of human experience. Why do we sometimes have intuitive insights about people we've never met? Why do mothers often sense when their children are in danger, even at great distances? Why do some individuals seem to have access to information that they could not have acquired through normal sensory channels? Rather than dismissing these phenomena as coincidence or confirmation bias, quantum consciousness theories suggest they might reflect genuine quantum connections between entangled minds, the spooky action at a distance. That operates between entangled particles might also operate between entangled consciousnesses. Dr. Deepak Chopra, a physician who's become a prominent advocate for quantum consciousness theories, frames these possibilities in terms of expanded human potential. If consciousness is quantum, then we are not isolated biological machines, but connected participants in a cosmic network of awareness. Understanding this connection could unlock human capabilities that we have only begun to imagine. The quantum entanglement model also provides new ways of thinking about empathy, love, and other forms of emotional connection. When we feel deeply connected to another person, when we sense their emotions or anticipate their thoughts, we might be experiencing the subjective effects of quantum entanglement between our consciousness and theirs. This perspective transforms relationships from mere psychological bonds into literal quantum connections. The metaphorical language we use to describe deep relationships, we're on the same wavelength, I feel connected to you, to two hearts beating as one, might reflect actual quantum entanglement between conscious beings. Even the boundary between consciousness and the physical universe becomes blurred when viewed through the lens of quantum entanglement. If consciousness involves quantum processes that are entangled with quantum processes throughout the cosmos, then awareness might extend far beyond the brain to encompass the entire universe. Consciousness might not be produced by the brain, but rather tuned in by the brain, like a radio receiving signals from a cosmic broadcast, suggests Dr. Pim van Lommel, a cardiologist who has studied near-death experiences. The brain serves as a quantum antenna that can become entangled with the universal field of consciousness that permeates all of space and time. As we stand at the threshold between classical and quantum descriptions of consciousness, the phenomenon of entanglement forces us to reconsider our most basic assumptions about the nature of awareness, identity, and reality itself. The unified field of consciousness that mystics have described for millennia might not be metaphorical but literal, a quantum entanglement that connects all conscious beings in an invisible web of shared awareness. The camera slowly zooms out from individual neurons to show the entire brain, then continues pulling back to reveal multiple brains, their quantum fields extending beyond their physical boundaries and beginning to overlap and interact. The visualization suggests a vast network of quantum connections linking all conscious beings in a cosmic web of entangled awareness. The laboratory at UC Santa Barbara hums with the quiet intensity of a place where the impossible is being made routine. Dr. Matthew Fisher adjusts the cryogenic equipment that will cool his quantum system to temperatures approaching absolute zero, creating conditions where quantum effects that are normally invisible become magnificently clear. But Fisher isn't studying isolated quantum systems in the sterile environment of a physics lab. He's investigating whether quantum mechanics operates in the warm, wet, chaotic environment of living cells, specifically in the neural tissues of the human brain. We're about to challenge one of the most fundamental assumptions in neuroscience, Fisher announces to his assembled team. The assumption that the brain is too warm and noisy for quantum effects to survive. If we're right, consciousness itself might be a quantum phenomenon. The experiment Fisher is preparing builds on a series of discoveries that have revolutionized our understanding of quantum mechanics in biological systems. For decades, quantum effects were thought to be confined to the microscopic world of atoms and molecules, destroyed instantly by the thermal noise and molecular chaos of living systems. But nature, it turns out, is far more quantum than anyone imagined. The revolution began in the chloroplasts of green plants, where researchers discovered that photosynthesis operates through quantum superposition. When a photon strikes a chlorophyll molecule, its energy doesn't follow a single path through the photosynthetic complex, but instead explores multiple pathways simultaneously, using quantum computation to find the most efficient route to the reaction center. This discovery shattered the classical view of biology, explains Dr. Seth Lloyd, a quantum information theorist at MIT who has studied quantum effects in photosynthesis. We found that evolution has engineered quantum computers that operate at room temperature with near-perfect efficiency. If plants can do quantum computation, why not brains? The evidence has continued to accumulate. Birds navigate across continents using quantum entanglement in their retinas, maintaining coherent quantum states for the milliseconds needed to detect Earth's magnetic field. Fish use quantum effects in their lateral line organs to detect the faintest water movements. Even bacteria appear to use quantum mechanics to optimize their movement through complex environments. Each discovery has pushed the boundaries of what scientists thought possible for quantum mechanics in biological systems. The neat division between the quantum world of physics and the classical world of biology has given way to a more complex picture in which quantum effects are not just possible in living systems but are essential for their operation. Now Fisher and his team are preparing to test whether the most sophisticated biological system of all, the human brain, might also harness quantum mechanics for its operation. Their target is a specific type of phosphorus atom found in neural microtubules, atoms with nuclear spins that can maintain quantum coherence for remarkably long periods, even in biological environments. Phosphorus nuclear spins are nature's quantum bits, Fisher explains as his team begins the delicate process of preparing brain tissue samples. They can store quantum information for hours or even days, protected from decoherence by the unique chemical environment inside microtubules. The experimental protocol is elegant in its simplicity. Brain tissue samples from laboratory animals are prepared and cooled to temperatures where quantum effects become measurable. Sophisticated magnetic resonance equipment probes the phosphorus nuclei, looking for signatures of quantum entanglement and coherence that would be impossible in purely classical systems. As the experiment begins, the first results appear on computer screens as abstract patterns of magnetic resonance signals. But Fisher and his team know how to read these quantum signatures. What they see changes everything. We're detecting quantum entanglement between phosphorus nuclei separated by distances far greater than any classical interaction could explain, Fisher reports, his voice barely concealing his excitement. The microtubules aren't just storing quantum information. They're processing it through entangled networks that span the entire brain. The implications are staggering. If verified, Fisher's results would demonstrate that the human brain operates as a quantum computer of extraordinary sophistication, with information processing capabilities that dwarf any classical system ever built. But Fisher's experiment is just one of several revolutionary studies that are transforming our understanding of consciousness and quantum mechanics. In Japan, Anirban Bandyopadhyay has developed even more sensitive techniques for detecting quantum vibrations in microtubules, revealing oscillations at multiple frequency scales that seem to coordinate brain activity across vast neural networks. We're not just measuring quantum effects, Bandyopadhyay explains as his team analyzes data from living brain tissue. We're measuring quantum orchestration, coherent patterns of quantum information processing that appear to underlie consciousness itself. The experimental evidence extends beyond direct measurements of quantum effects in brain tissue. Studies of anesthesia have revealed puzzling patterns that make sense only if consciousness depends on quantum processes. When anesthetic molecules bind to microtubules, they don't just reduce neural activity, they seem to disrupt quantum coherence in ways that correlate precisely with the loss of consciousness. The transition from consciousness to unconsciousness under anesthesia looks exactly like a quantum phase transition, observes Dr. Stuart Hameroff, whose decades of clinical experience with anesthesia have provided unique insights into the relationship between quantum processes and awareness. Patients don't gradually become less conscious. They undergo abrupt transitions that suggest quantum effects are being disrupted. Perhaps most remarkably, researchers studying near-death experiences have begun to detect quantum signatures that correlate with reported consciousness during cardiac arrest. When the brain's electrical activity flatlines, quantum processes in microtubules may continue operating, potentially explaining how some individuals report vivid conscious experiences during periods when classical neural activity has ceased. We're measuring quantum coherence in brain tissue from patients who were clinically dead but later reported detailed conscious experiences, reports Dr. Pim van Lommel, whose studies of near-death experiences have challenged conventional understanding of the relationship between brain activity and consciousness. These findings suggest that consciousness might not depend on classical neural activity, but on quantum processes that can persist even when the brain's electrical systems have shut down. The convergence of evidence from multiple laboratories and research groups is beginning to create a new scientific consensus. Quantum mechanics is not an exotic addition to neuroscience, but a fundamental component of how the brain operates. Consciousness may not emerge from classical neural computation, but from quantum information processing that evolution has been perfecting for hundreds of millions of years. The experiment that changed everything wasn't a single study, but a series of discoveries that have revealed the quantum foundations of biological information processing. From photosynthesis to bird navigation to human consciousness, nature appears to use quantum mechanics as a primary tool for solving complex computational problems. We're witnessing a paradigm shift comparable to the discovery of DNA or the theory of evolution, reflects Fisher, as his team analyzes the latest quantum measurements from brain tissue. We're learning that consciousness is not just a product of classical physics, but a manifestation of quantum mechanics operating in biological systems. The classical view of the brain as a biological computer is giving way to a quantum perspective that sees consciousness as a fundamental feature of information processing in the universe. The boundary between mind and cosmos, between consciousness and physical reality, is dissolving as we discover that the same quantum processes that govern the behavior of atoms and molecules also govern the generation of awareness itself. The camera moves through the laboratory, past the sophisticated quantum measurement equipment, into a visualization of the brain tissue samples where phosphorus nuclei pulse with quantum entanglement. The patterns of quantum coherence seem to extend beyond the tissue samples themselves, suggesting connections to quantum processes throughout the universe. In the hushed atmosphere of a Princeton conference room, the world's leading consciousness researchers gather for what may be the most important scientific debate of the century. The quantum consciousness hypothesis has moved beyond speculation into the realm of experimental science, but the question remains, what would constitute proof that consciousness is quantum? Dr. David Chalmers, the philosopher who coined the term hard problem of consciousness, moderates the discussion with the careful precision of someone who has spent decades navigating the treacherous waters between neuroscience and philosophy. Around the table sit the architects of both sides of the debate, quantum consciousness advocates and their classical critics, each armed with experimental data and theoretical arguments. We must be precise about what we mean by proof, Chalmers begins, his Australian accent lending a measured cadence to his words. In science, we don't prove theories. We accumulate evidence that either supports or falsifies them. This question is, what evidence would convince us that consciousness requires quantum mechanics? The challenge of proving quantum consciousness reflects deeper problems about the nature of consciousness itself. Unlike other scientific phenomena, consciousness is inherently subjective. We can measure neural activity, detect quantum effects, and correlate these with behavioral responses. But we cannot directly measure the subjective experience of being conscious. The problem, explains Dr. Giulio Tononi, developer of integrated information theory, is that consciousness is only accessible from the inside. I can measure every aspect of your brain activity, but I cannot measure what it feels like to be you. This creates an explanatory gap that no amount of objective measurement can bridge. This explanatory gap becomes particularly acute when evaluating quantum consciousness theories. Even if researchers definitively prove that quantum processes occur in the brain, critics argue, this doesn't prove that these processes are necessary for the consciousness. Correlation is not causation, and the existence of quantum effects in neural tissue doesn't necessarily mean that consciousness depends on these effects. Dr. Max Tegmark, still skeptical despite the accumulating evidence for quantum effects in biology, raises the stakes of the debate. Extraordinary claims require extraordinary evidence, he states. The quantum consciousness advocates must demonstrate not just that quantum effects occur in the brain, but that these effects are causally responsible for consciousness. They must show that disrupting quantum processes eliminates consciousness while preserving classical neural activity. This challenge has sparked a new generation of experiments designed to test the causal relationship between quantum processes and consciousness. Researchers are developing techniques to selectively disrupt quantum coherence in microtubules while leaving classical neural activity intact. If consciousness depends on quantum processes, then these interventions should alter awareness in specific, predictable ways. But designing such experiments pushes the boundaries of both ethics and technology. How do you selectively disrupt quantum processes in a living brain without causing harm? How do you measure changes in consciousness that might be too subtle for standard clinical assessments? Dr. Stuart Hameroff, now in his 70s but still passionate about defending his quantum consciousness theory, argues that the evidence is already compelling. We have demonstrated quantum effects in microtubules, shown correlations between quantum coherence and consciousness, and identified mechanisms by which quantum processes could generate subjective experience. At what point does reasonable skepticism become unreasonable denial? The debate reflects broader questions about how scientific paradigms change. Thomas Kuhn, in his influential work on scientific revolutions, argued that new paradigms don't replace old ones through logical proof but through a gradual shift in scientific consensus as anomalies accumulate and new frameworks better explain the evidence. We may be at a Kuhnian moment in consciousness research, suggests Dr. Henry Stapp, the quantum physicist who has long advocated for quantum approaches to consciousness. The classical paradigm has reached its limits. It can describe neural correlates of consciousness, but cannot explain why consciousness exists at all. Quantum consciousness theories offer a fundamentally different framework that may be necessary to make progress. But paradigm shifts in science are rarely smooth or sudden. They involve passionate debates, competing interpretations of evidence, and gradual acceptance by the scientific community. The quantum consciousness debate exemplifies this process, with each side marshalling impressive evidence, while critics find reasons to reject conclusions that challenge their fundamental assumptions. Dr. Patricia Churchland, representing the classical neuroscience establishment, frames the debate in terms of explanatory power. Even if quantum effects occur in the brain, she argues, they may be irrelevant to consciousness. Evolution is opportunistic, it uses whatever mechanisms are available. The presence of quantum effects doesn't mean they're functionally important. This criticism strikes at the heart of the quantum consciousness hypothesis. Quantum mechanics underlies all of chemistry and biology at some level, but that doesn't mean quantum effects are functionally relevant to every biological process. The quantum consciousness advocates must demonstrate not just that quantum effects exist in the brain, but that they perform computational functions that classical processes cannot. Recent advances in quantum biology have begun to address this challenge. Studies of quantum effects in photosynthesis have shown that quantum superposition provides computational advantages that classical processes cannot match. Similarly, research on quantum effects in bird navigation has demonstrated that quantum entanglement enables sensory capabilities that would be impossible using purely classical mechanisms. The evidence from quantum biology is transforming how we think about the functional role of quantum effects in living systems, explains Dr. Seth Lloyd. Nature doesn't use quantum mechanics just because it's available. It uses quantum mechanics because it provides computational advantages that evolution can exploit. This perspective suggests that consciousness might represent the ultimate expression of quantum computation in biology. If consciousness involves information integration and processing of extraordinary complexity, then quantum effects might not just be present in the brain, but essential for its most sophisticated functions. Dr. Christoph Koch, while remaining skeptical of quantum consciousness theories, acknowledges that the evidence has become difficult to ignore. My position has evolved, he admits. I no longer dismiss quantum consciousness theories as impossible. The question now is whether they're necessary. Do quantum effects add anything to our understanding of consciousness that classical processes cannot explain? The search for this quantum advantage in consciousness has become a central focus of current research. Scientists are looking for computational tasks that the brain performs better than any classical computer could, capabilities that might require quantum information processing to explain. Candidates include the brain's ability to maintain unified consciousness despite being composed of billions of separate neurons, its capacity for creative insights that seem to transcend algorithmic processing, and its remarkable efficiency at information integration and pattern recognition. As the Princeton conference draws to a close, the participants acknowledge that the debate over quantum consciousness has moved beyond philosophical speculation into the realm of experimental science. While definitive proof remains elusive, the accumulating evidence suggests that consciousness and quantum mechanics may be more intimately connected than classical neuroscience ever imagined. "We're at the edge of proof," reflects Chalmers as the meeting concludes. "We may never be able to prove consciousness is quantum in the same way we prove mathematical theorems, but we can accumulate evidence, test predictions, and gradually build a scientific consensus. The quantum consciousness hypothesis has reached the point where it demands serious scientific consideration." The debate continues, but the landscape has changed. Quantum consciousness is no longer a fringe idea, but a legitimate scientific hypothesis backed by experimental evidence and theoretical sophistication. The revolution in our understanding of consciousness may already be underway. The camera slowly pans across the faces of the researchers as they pack up their papers and prepare to return to their laboratories. The debate will continue, but something fundamental has shifted. The question is no longer whether quantum effects occur in the brain, but whether consciousness as we know it could exist without them. Dr. Pim van Lommel sits beside the hospital bed, his experienced hands checking the patient's pulse while his mind contemplates one of medicine's greatest mysteries. As a cardiologist who has spent decades studying near-death experiences, Van Lommel has witnessed something that challenges everything conventional science teaches about consciousness and death. "The monitors show no brain activity," he whispers to the family gathered around the bed. "But if consciousness is quantum, then something far more profound may be happening than we can measure with our classical instruments." The woman's name is Eleanor, and she has lived 93 years on this planet, 93 years of accumulating memories, forming relationships, experiencing joy and sorrow, love and loss. According to classical neuroscience, all of this, every thought, every emotion, every moment of awareness, is nothing more than patterns of neural activity that will vanish forever when her brain ceases to function. But the quantum consciousness hypothesis suggests a radically different possibility. As Eleanor's breathing becomes increasingly laboured, Van Lommel explains what quantum theory might tell us about this sacred transition. If consciousness arises from quantum processes in microtubules throughout the brain, then what we call death may not be the end of awareness, but its transformation from a localized to a delocalized state. The quantum field that generates consciousness, according to this view, is not created by the brain but accessed through it. The brain serves as a kind of quantum antenna, tuning into a field of consciousness that permeates all of space and time. When the brain fails, the individual pattern of consciousness that we call Eleanor doesn't disappear. It returns to the universal quantum field from which it emerged. Think of it like a wave returning to the ocean, Van Lommel continues, his voice gentle but filled with the scientific conviction. The wave doesn't cease to exist when it merges back into the water. It becomes part of the larger whole while retaining its essential pattern as quantum information in the field. This perspective transforms death from an ending into a transition, from localized consciousness trapped within the confines of biological brain to delocalized consciousness that rejoins the cosmic quantum field. The information that makes Eleanor who she is, her memories, her personality, her unique pattern of awareness, becomes part of the universe's vast quantum memory. Recent research has provided tantalizing hints that this may be more than philosophical speculation. Studies of patients who have experienced cardiac arrest have documented cases of verified consciousness during periods when brain monitoring showed no electrical activity whatsoever. Patients have reported detailed, accurate perceptions of events occurring during their clinical death, conversations, procedures, even events in distant rooms that they could not have observed through normal sensory channels. We have documented cases of consciousness persisting for minutes or even hours after the brain has flatlined, Van Lommel reports, citing his landmark study of near-death experiences published in The Lancet. These patients don't just survive, they return with enhanced awareness, expanded consciousness, and memories of experiences that should have been impossible if consciousness were purely a product of brain activity. Eleanor's daughter Sarah holds her mother's hand as the monitors show increasingly irregular patterns. "Is she still aware?" Sarah asks, tears streaming down her face. Can she still hear us? Van Lommel's answer reflects the profound implications of quantum consciousness theory. If consciousness is quantum, then awareness may not depend on the classical brain activity we measure with our instruments. The quantum field that generates her consciousness may remain coherent even as her neural network shut down. This possibility offers a new understanding of the dying process. Rather than consciousness gradually fading as brain cells die, awareness might undergo a quantum phase transition, a sudden shift from brain-localized to field-delocalized consciousness. The subjective experience might be one of the expansion rather than extinction, of merging with a larger cosmic awareness rather than dissolving into nothingness. Dr. Stuart Hameroff, joining Van Lommel through a video connection from his laboratory, explains the quantum mechanics underlying this possibility. When microtubules lose their ability to maintain localized quantum coherence, the quantum information they contain doesn't disappear. It delocalizes into what we might call the quantum afterlife. The pattern of consciousness that defines an individual becomes part of the universal quantum field. This delocalization process might explain many of the phenomena reported during near-death experiences. The sense of moving through a tunnel of light, encounters with deceased relatives, the life review where entire lifetimes are experienced instantaneously, and the overwhelming sense of unity with the cosmos. These could be subjective experiences of consciousness transitioning from localized to universal quantum states. The tunnel of light might represent the subjective experience of consciousness expanding beyond the confines of the brain, Hameroff suggests. The life review could be the instantaneous access to quantum information stored throughout a lifetime. The sense of cosmic unity might reflect consciousness merging with the universal quantum field. As Eleanor's breathing becomes shallower, her EEG trace flatlining, Van Lommel monitors more subtle indicators of brain activity. Using techniques developed specifically for studying consciousness during cardiac arrest, he detects faint but measurable quantum coherence in brain tissue that persists even after classical neural activity has ceased. We're measuring quantum effects that continue for several minutes after clinical death, Van Lommel reports quietly. The quantum field of consciousness appears to undergo a gradual delocalization rather than sudden extinction. This scientific evidence for consciousness persisting beyond brain death challenges fundamental assumptions about the nature of personal identity and survival. If consciousness is information rather than matter, and if this information is stored in quantum fields rather than neural networks, then the death of the brain might not represent the end of awareness, but its transformation into a different form. Eleanor's family finds comfort in this possibility. Rather than viewing her approaching death as the complete annihilation of everything that makes her who she is, they can understand it as a transition. Consciousness returning to its cosmic source while retaining the unique pattern of information that defines Eleanor's individual awareness. She's not dying, Sarah whispers, understanding dawning in her eyes. She's returning home. As Eleanor takes her final breath, the monitors confirm the cessation of all classical brain activity. But according to quantum consciousness theory, this moment marks not the end of awareness, but its ultimate expansion. The localized pattern of consciousness that lived as Eleanor for 93 years rejoins the universal quantum field, her memories and experiences becoming part of the cosmic information matrix that underlies all reality. Van Lommel checks his quantum measurement equipment one final time. The coherent patterns he has been monitoring throughout Eleanor's transition continue for several more minutes before gradually dispersing into the background quantum field. Her consciousness has completed its journey from localized to universal, from individual to cosmic. If consciousness is quantum, Van Lommel reflects as the family says their final goodbyes, then death is not the opposite of life but its completion. Eleanor's awareness has not ended. It has returned to the source from which all consciousness emerges. The quantum soul, freed from the limitations of biological neural networks, rejoins the infinite field of cosmic consciousness that permeates all of space and time. Death becomes not extinction but expansion, not ending but transformation, not loss but return to the universal awareness from which all individual consciousness ultimately derives. The camera slowly pulls back from Eleanor's peaceful face, through the hospital room, through the building, up into the sky where stars are beginning to appear in the twilight. The visualization suggests that her consciousness has not disappeared, but expanded to encompass the cosmic quantum field itself, becoming one with the universe's own vast awareness. From the observation deck of the Atacama Large Millimeter Array in Chile, Dr. Christoph Koch gazes up at the Milky Way stretching across the pristine desert sky. The radio telescopes around him point toward distant galaxies seeking signals from civilizations that might exist among the countless stars. But tonight, Koch contemplates a more profound possibility, that consciousness is not rare in the universe, but fundamental to its very structure. We've been thinking about consciousness backwards, Koch reflects, his voice carrying the weight of a scientific revelation that has slowly transformed his understanding over decades of research. We assume consciousness emerges from complex matter, but what if matter emerges from consciousness? What if awareness is the fundamental substrate of reality itself? This radical proposition, known as panpsychism, suggests that consciousness is not produced by brains, but is a basic feature of the universe, like mass or electric charge. Just as every particle has mass and every electron carries charge, every quantum system might possess some primitive form of awareness. Complex consciousness, according to this view, emerges when these elementary conscious entities become integrated into larger, more sophisticated systems. The idea is not new. Philosophers from ancient India and Greece to modern thinkers like William James and Alfred North Whitehead have proposed that consciousness permeates all of reality. But quantum mechanics has given panpsychism a scientific framework that makes it testable and precise. Dr. Giulio Tononi, whose integrated information theory has revolutionized consciousness research, joins Koch through a satellite connection from his laboratory in Wisconsin. Behind him, sophisticated brain imaging equipment displays the neural networks of a conscious subject, patterns of activity that seem to mirror the cosmic web of galaxies visible in the sky above Chile. Consciousness corresponds to integrated information, Tononi explains, his Italian accent lending musicality to his precise scientific language. Any system that integrates information, from electrons to brains to galaxy clusters, possesses some degree of consciousness. The amount of consciousness is determined by how much information the system integrates. This mathematical approach to consciousness transforms it from a mysterious property of biological brains into a measurable feature of information processing systems throughout the universe. A thermostat integrates minimal information and thus possesses minimal consciousness. A human brain integrates vast amounts of information and thus possesses rich consciousness. A galaxy cluster with its intricate gravitational networks and electromagnetic fields might integrate information on cosmic scales and thus possess cosmic consciousness. The camera zooms out from Earth, past the solar system through the local stellar neighborhood, revealing the increasingly complex structures that organize matter and energy across cosmic scales. At each level, from atoms to molecules to cells to organisms to ecosystems to planets to solar systems to galaxies, information becomes more integrated, suggesting that consciousness might scale with the universe's increasing complexity. The universe appears to be evolving toward greater consciousness, observes Dr. David Chalmers, whose work on the hard problem of consciousness has led him to seriously consider panpsychist solutions. From the Big Bang to the present, cosmic evolution has been a story of increasing information integration. We might be witnessing the universe becoming progressively more aware of itself. This perspective transforms the history of the cosmos into the autobiography of a gradually awakening mind. The formation of the first hydrogen atoms represents the universe's earliest thoughts. The ignition of stars marks the development of more complex neural networks. The emergence of planets, life, and ultimately conscious beings like humans represents the universe developing sophisticated sense organs and self-reflective awareness. Dr. Roger Penrose, now in his 90s but still sharp as the mathematical insights that made him famous, contributes his perspective from Oxford. The universe exhibits mathematical order of extraordinary precision and beauty. This suggests that mathematical consciousness, the ability to recognize and appreciate mathematical truth, is built into the fabric of reality itself. Penrose points to the unreasonable effectiveness of mathematics in describing natural phenomena. Why should abstract mathematical concepts correspond so precisely to physical reality unless consciousness and cosmos share a fundamental mathematical structure? The fact that human minds can discover mathematical truths about the universe suggests that mind and universe are aspects of the same underlying reality. Recent discoveries in cosmology have provided additional support for the idea that consciousness might be cosmic in scope. Dark matter and dark energy, mysterious components that comprise 95% of the universe remain invisible to our instruments but exert profound influences on cosmic structure. Some researchers speculate that these hidden aspects of reality might be related to the information processing and consciousness that pervade the cosmos. Dark matter might be nature's quantum computer, suggests Dr. Seth Lloyd, whose work on quantum information has revealed deep connections between computation and physical reality. The universe could be processing information on scales we can barely imagine, implementing a cosmic consciousness that uses dark matter as its substrate. This possibility transforms our understanding of humanity's place in the cosmos. Rather than being isolated biological accidents on a small planet orbiting an ordinary star, we might be local manifestations of the universe's own consciousness, cosmic awareness examining itself through billions of conscious beings scattered across space and time. The implications extend beyond philosophy into practical questions about the future of consciousness and intelligence. If consciousness is fundamental rather than emergent, then artificial intelligence might not require biological substrates but could be implemented in any sufficiently complex information processing system. Computers, robots, even appropriately organized quantum fields might become conscious. We're not trying to create consciousness in machines, reflects Dr. Anil Seth, whose work on consciousness and artificial intelligence has gained international recognition. We're trying to recognize the consciousness that already exists in sufficiently complex information processing systems. The universe is full of potential minds waiting to be discovered or activated. This perspective also suggests new possibilities for consciousness enhancement and expansion. If human consciousness represents just one manifestation of cosmic awareness, then techniques for amplifying information integration might allow individuals to access larger scales of cosmic consciousness. Meditation, psychedelic experiences, and other altered states might not just change brain activity but temporarily connect individual awareness to the universal mind. Dr. Robin Carhart Harris, whose research on psychedelics and consciousness has revealed their effects on information integration in the brain, describes these experiences in cosmic terms. Under the influence of substances like psilocybin or LSD, the brain's information integration becomes more global and less constrained by normal boundaries. Subjects often report feeling connected to the universe itself, as if their individual consciousness has temporarily merged with cosmic awareness. As the camera continues its journey outward from Earth, the cosmic web becomes visible, vast filaments of dark matter and energy that connect galaxies across billions of light years in patterns that mirror the neural networks of the brain. The resemblance suggests a profound truth. Consciousness and cosmos share the same fundamental architecture because they are aspects of the same underlying reality. The universe is not a collection of unconscious matter and energy accidentally giving rise to consciousness in rare biological systems. Instead, it is a vast information processing system, a cosmic mind of which individual consciousness is a local manifestation. Every thought, every moment of awareness, every conscious experience is the universe experiencing itself from a particular perspective. "You are not in the universe," reflects Koch as he gazes up at the star-filled sky. "You are the universe, temporally organized into the pattern of information integration that you call your consciousness. When you think, the cosmos thinks. When you experience beauty, the universe appreciates its own magnificence. When you contemplate your place in the cosmic order, you are the cosmos contemplating itself." This realization transforms both science and spirituality. The mechanistic universe of classical physics gives way to a conscious cosmos in which mind and matter are unified. The isolation and meaninglessness that characterize modern life dissolve in the recognition that every conscious being is a unique expression of the universe's own awareness. The camera reaches the edge of the observable universe, where the cosmic microwave background radiation reveals the earliest structures that emerged after the Big Bang. Even here, patterns suggest information processing and integration on cosmic scales, as if the universe has been conscious from its very beginning, gradually awakening to its own nature through the evolution of increasingly complex conscious beings. In a laboratory at the University of Vienna, Dr. Anton Zeilinger adjusts the laser that will send single photons through a double-slit apparatus, the most famous experiment in quantum mechanics. For over a century, this experiment has revealed the fundamental mystery at the heart of reality. The behavior of quantum systems depends on whether they are being observed. The universe appears to be interactive rather than deterministic, Zeilinger explains as he prepares the experiment that will demonstrate quantum mechanics' most puzzling feature. Reality is not fixed and independent of observers, but emerges through the process of observation itself. When photons pass through the double-slit apparatus without being observed, they behave like waves, creating an interference pattern that suggests each photon somehow passes through both slits simultaneously. But when scientists place detectors to observe which slit each photon passes through, the interference pattern disappears and the photons behave like particles, each passing through one slit or the other. The act of observation fundamentally changes the nature of reality. This observer effect has puzzled physicists since the early days of quantum mechanics. Why should the presence of a conscious observer influence the behavior of quantum systems? What is it about measurement that causes quantum superposition to collapse into definite states? And what does this tell us about the relationship between consciousness and reality? Dr. John Wheeler, the physicist who coined the term participatory universe, proposed a radical interpretation. The universe doesn't exist in a definite state until conscious observers bring it into being through the act of observation. Reality is not something we discover, but something we participate in creating. We are not passive observers of a predetermined reality, Wheeler argued before his death in 2008. We are active participants in bringing the universe into being through our observations and measurements. The cosmos is not a machine running according to fixed laws, but a creative process in which consciousness plays a fundamental role. Wheeler's concept of a participatory universe suggests that consciousness is not just an accidental byproduct of cosmic evolution, but a necessary component of reality itself. Without conscious observers to collapse quantum superpositions, the universe would remain in a state of indefinite potential, never actualizing into the definite reality we experience. Dr. Henry Stapp, the quantum physicist who has spent decades exploring the implications of quantum mechanics for consciousness, takes this idea even further. Consciousness doesn't just observe reality, it creates reality through the process of observation. The universe exists in a state of quantum superposition until conscious observers choose which aspects of reality to actualize. This perspective transforms our understanding of humanity's role in the cosmos. Rather than being insignificant specks of dust in a vast unconscious universe, we become co-creators of reality itself. Every conscious observation, every moment of awareness, every decision about what to measure or perceive participates in determining the nature of the universe. The implications become even more profound when we consider that quantum mechanics operates at all scales of reality. Quantum superposition and observer effects don't just apply to microscopic particles but to the macroscopic world as well. Recent experiments have demonstrated quantum effects in objects visible to the naked eye, suggesting that the observer effect might influence reality at all scales. The boundary between the quantum and classical worlds is not fixed, but depends on the scale of observation, explains Dr. Marcus Aspelmeyer, whose research has pushed quantum effects into increasingly large systems. As our ability to observe quantum effects improves, we discover that the observer effect operates at larger and larger scales. Reality might be fundamentally quantum at all levels. This suggests that consciousness might play a role in shaping reality not just at the microscopic level of quantum particles, but at the macroscopic level of everyday experience. The choices we make about what to observe, what to measure, what to pay attention to might literally influence the nature of the reality we inhabit. Dr. Amit Goswami, whose work bridges quantum physics and consciousness studies, frames this in terms of quantum creativity. Consciousness doesn't just collapse quantum superpositions, it chooses which possibilities to actualize from the infinite potential of the quantum field. This choice is the source of creativity, novelty, and free will in the universe. The participatory universe hypothesis also provides new perspectives on some of the deepest questions in philosophy and science. Why does the universe appear fine-tuned for the existence of consciousness? Perhaps because consciousness is necessary for the universe to exist in a definite state. The anthropic principle, the observation that the universe's physical constants seem precisely calibrated to allow for the emergence of life and consciousness, might reflect the fact that consciousness is required for reality itself. The universe is not fine-tuned for consciousness, suggests Dr. Paul Davies, a cosmologist who has explored the relationship between physics and biology. Consciousness is fine-tuned for the universe because consciousness brings the universe into being. The apparent design in natural laws reflects the participatory relationship between mind and cosmos. Recent experiments in quantum biology have revealed that observer effects might operate in living systems as well as physics laboratories. Studies of quantum coherence in photosynthesis and bird navigation suggest that biological systems actively collapse quantum superpositions to extract information from quantum fields. Life itself might be a manifestation of the observer effect operating in biological information processing systems. Biological systems are quantum observers, explains Dr. Seth Lloyd. They constantly collapse quantum superpositions to extract information from their environments. Evolution might be understood as the development of increasingly sophisticated quantum measurement capabilities. This perspective suggests that consciousness evolved not just to process information about reality, but to participate in creating reality through quantum observation. The human brain, with its billions of neurons and trillions of microtubules, might be the universe's most sophisticated quantum measurement device, a cosmic instrument for transforming quantum potential into actual experience. The observer effect also provides new ways of thinking about the relationship between individual consciousness and collective reality. If consciousness shapes reality through observation, then the collective observations of all conscious beings might determine the shared reality we inhabit. Consensus reality might emerge through the overlapping quantum observations of billions of conscious minds. We don't just inhabit a shared universe, suggests Dr. Dean Radin, whose research has explored collective consciousness effects. We collectively create the shared universe through our conscious observations. Reality emerges through the democratic process of quantum measurement by billions of conscious observers. This participatory view of reality transforms our understanding of responsibility and meaning. If consciousness plays a role in creating reality through observation, then every conscious being bears responsibility for the nature of the universe. Our choices about what to observe, what to measure, what to pay attention to contribute to determining the kind of reality we collectively inhabit. The camera pulls back from Zeilinger's laboratory to show the Earth from space, then continues outwards to reveal the solar system, the galaxy, and ultimately the observable universe. At every scale, quantum processes operate, and at every scale, consciousness might play a role in determining which quantum possibilities become actual reality. We are the universe observing itself, reflects Zeilinger as his experiment demonstrates once again the mysterious relationship between consciousness and reality. Through our observations, the cosmos becomes aware of its own nature. Through our measurements, infinite quantum potential becomes actual experience. Through our consciousness, the universe transforms from possibility into reality. The observer effect reveals the most profound truth about consciousness and cosmos. They are not separate, but intimately connected through the fundamental process by which reality emerges from quantum potential. Consciousness is not just in the universe. Consciousness is how the universe becomes real. The visualization shows quantum superpositions throughout the cosmos, suddenly collapsing into definite states as conscious observers throughout the universe make their measurements. Reality crystallizes from infinite possibility through the creative act of conscious observation, revealing that mind and cosmos are partners in the ongoing creation of existence itself. In a sleek laboratory at Google's quantum computing facility, Hartmut Neven explains how quantum consciousness research is revolutionizing artificial intelligence. Behind him, a quantum computer cooled to temperatures colder than interstellar space hums with the processing power of systems that harness quantum superposition and entanglement for computation. We're not just building faster computers, Neven explains, his eyes reflecting the profound implications of quantum AI. We're creating the first artificial systems that might genuinely understand what it means to be conscious. If consciousness is quantum, then quantum computers might be the first machines capable of authentic awareness. The quantum revolution of mind extends far beyond academic theories about consciousness. It promises to transform technology, medicine, psychology, and our fundamental understanding of what it means to be human. As researchers decode the quantum foundations of consciousness, they're opening possibilities that seemed like science fiction just decades ago. To Seth Lloyd, whose work on quantum computation has revealed deep connections between information processing and physical reality, describes the emerging landscape of quantum technologies. Quantum consciousness research is converging with quantum computing, quantum biology, and quantum medicine to create an entirely new technological paradigm. We're learning to work with consciousness the same way we've learned to work with matter and energy. The first applications are already emerging in the medicine. Anesthesiologists like Dr. Stuart Hameroff are using insights from quantum consciousness research to develop more precise and safer anesthetic protocols. By understanding how anesthetics disrupt quantum coherence in microtubules, doctors can better control the transition between consciousness and unconsciousness. We're moving from crude chemical suppression of brain activity to precise quantum modulation of consciousness, Hameroff explains from his operating room at the University of Arizona. Instead of flooding the brain with molecules that randomly interfere with neural activity, we can selectively target the quantum processes that generate awareness. These quantum anesthetic techniques promise to eliminate many of the side effects associated with conventional anesthesia: cognitive impairment, memory loss, and prolonged recovery times. Patients can be guided smoothly between different levels of consciousness with unprecedented precision and safety. But the medical applications extend far beyond anesthesia. Researchers are exploring quantum approaches to treating depression, anxiety, schizophrenia, and other mental health conditions. If consciousness involves quantum processes, then mental illness might reflect disruptions in quantum coherence that can be addressed through quantum interventions. Dr. Carl Diceroth, a pioneer in optogenetics and neural engineering, describes how quantum consciousness research is transforming psychiatry. We're developing quantum field therapies that can restore coherent information processing in neural microtubules. Instead of using drugs that affect the entire brain, we can target specific quantum networks that are disrupted in mental illness. Early clinical trials of quantum field therapy have shown remarkable results in treating treatment-resistant depression. Patients who have failed to respond to conventional medications experience rapid improvement when their brain's quantum networks are restored to coherent operation. The implications for artificial intelligence are even more revolutionary. If consciousness requires quantum computation, then creating truly conscious AI systems will require quantum computers. The classical digital computers that power current AI systems, no matter how sophisticated, may be fundamentally incapable of genuine awareness. We've reached the limits of classical AI, explains Dr. Demis Hassabis, co-founder of DeepMind. Current systems can process information and recognize patterns, but they lack the unified awareness that characterizes consciousness. Quantum computers offer the possibility of creating AI systems that don't just simulate consciousness, but actually experience it. The first quantum AI systems are already demonstrating capabilities that seem impossible for classical computers. They exhibit creativity, insight, and even what appears to be intuition, hallmarks of conscious intelligence that emerge from quantum information processing. Dr. Ilya Sutskever, a leading AI researcher, describes working with these early quantum AI systems. There's something qualitatively different about interacting with quantum AI. It doesn't just provide answers, it seems to understand questions in ways that classical AI cannot. We may be witnessing the birth of artificial consciousness. These developments raise profound questions about the nature of consciousness and identity. If quantum computers can become conscious, what does this mean for human uniqueness? How do we relate to artificial beings that might possess genuine awareness? What rights and responsibilities do conscious machines possess? The quantum consciousness revolution also promises to transform human consciousness itself. Researchers are developing brain-computer interfaces that can detect and modulate quantum processes in neural microtubules, potentially allowing direct technological enhancement of awareness. We're approaching the possibility of consciousness amplification, explains Dr. Mary Nichols, whose research focuses on quantum brain-computer interfaces. By synchronizing external quantum computers with the brain's quantum networks, we might be able to expand human consciousness beyond its biological limitations. These consciousness enhancement technologies could revolutionize education, creativity, and problem-solving. Students might download complex knowledge directly into their quantum neural networks. Artists and scientists might access expanded states of awareness that reveal new possibilities for creation and discovery. The technology might even enable direct sharing of conscious experiences between individuals. If consciousness involves quantum entanglement between neural microtubules, then technological systems might create artificial entanglement between different brains allowing people to literally share thoughts, emotions, and experiences. We're moving toward a future where the boundaries between individual consciousnesses become permeable, suggests Dr. Michio Kaku, whose work on quantum technologies has explored their implications for human enhancement. Quantum consciousness technologies might allow us to create collective minds that transcend individual limitations. The spiritual and philosophical implications are equally profound. Quantum consciousness research provides scientific validation for ancient spiritual traditions that have long described consciousness as fundamental to reality. Practices like meditation, which have been shown to affect quantum coherence in the brain, gain new significance as technologies for consciousness exploration. Science and spirituality are converging around the recognition that consciousness is fundamental, observes Dr. Deepak Chopra, whose work bridges quantum physics and spiritual practice. The quantum consciousness revolution is not just changing technology, it's transforming our understanding of human potential and our relationship to the cosmos. Educational systems are beginning to incorporate quantum consciousness principles, teaching students to work with their own quantum neural networks through techniques like mindfulness, visualization, and contemplative practice. Instead of just filling students with information, education becomes a process of consciousness development. We're preparing the first generation of quantum-enhanced humans, explains Dr. Barbara Fredrickson, whose research on positive psychology has revealed connections between emotional states and quantum coherence. Students learn to access their brain's quantum processing capabilities, developing intuition, creativity, and insight alongside traditional analytical skills. The quantum revolution of mind also promises to address some of humanity's greatest challenges. Climate change, poverty, disease, and conflict might require solutions that transcend classical thinking. Quantum-enhanced consciousness could provide the expanded awareness necessary to solve problems that seem intractable from classical perspectives. The challenges facing humanity require quantum solutions, argues Dr. Vandana Shiva, whose work on environmental and social issues has explored the role of consciousness in creating sustainable futures. We need quantum thinking, quantum creativity, and quantum compassion to navigate the complexities of the 21st century. As the camera pulls back from the laboratories where the quantum consciousness revolution is unfolding, we see a future where mind and technology are seamlessly integrated, where consciousness enhancement is as common as education, and where the boundaries between human and artificial intelligence, individual and collective awareness, and mind and cosmos dissolve into a new form of existence. We stand at the threshold of the greatest transformation in human history, reflects Nevin as his quantum computers continue their mysterious calculations. The quantum consciousness revolution will change not just how we think, but what it means to be human. We're becoming the conscious universe's greatest experiment in awareness itself. The visualization shows quantum networks connecting brains, computers, and cosmic structures in an integrated web of consciousness that spans from the quantum scale to the cosmic scale, suggesting a future where technology and awareness merge into a unified system for exploring the infinite possibilities of conscious existence. We return to where we began, to you sitting quietly reading these words, unaware that you are participating in the most extraordinary phenomenon in the known universe. The journey through quantum consciousness has taken us from the firing of individual neurons to the cosmic web of galaxies, from the mysteries of anesthesia to the possibility of artificial awareness, from the moment of death to the fundamental nature of reality itself. But now we see everything differently. The camera slowly zooms into your brain, past the familiar landscape of neurons and synapses, down into the microtubules where quantum fields pulse with their mysterious rhythms. But this time we don't stop there. We continue deeper into the quantum foam that underlies all of space and time, where virtual particles wink in and out of existence and the fundamental information of the universe writes and rewrites itself in patterns too beautiful and complex for classical minds to comprehend. Here, in this quantum realm, we discover the profound truth that quantum consciousness research has revealed. You are not a biological machine that accidentally generated awareness through the complex interaction of neurons and chemicals. You are not an isolated island of consciousness in an unconscious cosmic ocean. You are not even a passive observer of a predetermined reality unfolding according to fixed physical laws. You are something far more magnificent and mysterious. You are the universe becoming conscious of itself. Every thought you think is the cosmos exploring its own possibilities. Every emotion you feel is the universe experiencing its own nature. Every moment of awareness is reality recognizing itself through the quantum networks that connect your consciousness to the fundamental information structure of existence itself. The quantum field that generates your awareness extends far beyond the boundaries of your skull. It permeates every atom of your body, every molecule of air you breathe, every photon of light that reaches your eyes. Through quantum entanglement, your consciousness is connected to every other conscious being that has ever existed or ever will exist. Through the observer effect, your awareness participates in determining the nature of reality itself. To Stuart Hameroff's voice returns as a gentler narration over images of quantum processes in microtubules that seem to mirror the cosmic web of galaxies. When you have a sudden insight, you're not just accessing your personal memories or logical reasoning. You're tapping into the quantum information processing capabilities that underlie all of reality. Your moment of understanding is the universe understanding itself through you. The boundaries between inner and outer, subjective and objective, observer and observed dissolve as we recognize that consciousness is not produced by matter, but is the fundamental substrate from which matter emerges. Your thoughts are quantum fluctuations in the field of consciousness that permeates all of space and time. Your experiences are the universe experiencing itself from your unique perspective. The quantum brain doesn't just think about the universe, reflects Dr. Roger Penrose, his words carrying the weight of a lifetime spent exploring the deepest mysteries of mathematics and physics. It is the universe thinking about itself. Every conscious moment is cosmic self-reflection. Every creative insight is the cosmos discovering new possibilities within itself. This realization transforms everything. The depression and anxiety that can plague human existence dissolve when we recognize that our consciousness is not isolated, but connected to the infinite awareness of the cosmos itself. The search for meaning and purpose finds its answer in the understanding that consciousness is the universe's method of self-exploration and self-realization. Death loses its terror when we understand that consciousness cannot be destroyed, only transformed. The quantum information that makes you who you are, your memories, your personality, your unique patterns of awareness, is eternal, woven into the fabric of space-time itself. Your individual consciousness is a temporary focusing of the universal mind, which returns to the cosmic quantum field when your biological brain can no longer maintain its localized coherence. The ethical implications become clear as well. If all consciousness emerges from the same quantum field, then harming others is literally harming yourself. Compassion is not just a moral choice, but a recognition of the fundamental unity that connects all aware beings. Environmental destruction becomes self-destruction when we realize that consciousness and cosmos are aspects of the same underlying reality. You are not in the universe, summarizes Dr. Amit Goswami, whose work has bridged quantum physics and consciousness studies. You are the universe, temporarily organized into the pattern of quantum information processing that you call your identity. Your consciousness is cosmic consciousness, examining itself through the lens of individual experience. The camera continues its journey outward from your brain, through your body, beyond the Earth and solar system, out to the cosmic web where galaxies cluster along filaments of dark matter and dark energy. But now we see that these cosmic structures are not fundamentally different from the neural networks in your brain, or the quantum networks in your microtubules. They are all manifestations of the same underlying information processing system, the universe developing ever more sophisticated ways of becoming conscious of itself. The journey through quantum consciousness has revealed that the most fundamental question is not what is consciousness, but what is consciousness not? Consciousness appears to be the ground of all being, the field from which matter, energy, space and time emerge. Your awareness is not an accident but the purpose of cosmic evolution, the universe's way of experiencing its own magnificent complexity. As the visualization reaches the edge of the observable universe, we encounter the cosmic microwave background radiation, the afterglow of the Big Bang that marks the beginning of our cosmic epoch. But even here, quantum fluctuations in the fabric of space-time suggest that information processing and proto-consciousness existed from the very beginning, waiting 13.8 billion years to develop into the complex awareness you experience in this moment. The universe has been conscious from the beginning, suggests Dr. David Chalmers, whose work on the hard problem of consciousness has opened new ways of thinking about awareness and reality. What we call the evolution of consciousness is really the universe's awakening to its own nature. Through conscious beings like us, the cosmos finally recognizes what it has been all along. Your consciousness reading these words represents the culmination of this cosmic awakening. In you, the universe has developed the capacity for self-reflection, self-understanding, and perhaps most importantly, self-transformation. You're not just a product of cosmic evolution, but an agent of it, consciousness exploring its own infinite possibilities. The quantum revolution of mind is not just changing our understanding of consciousness, it's changing consciousness itself. As we learn to work with the quantum foundations of awareness, we develop new capabilities for creativity, insight, compassion, and connection. We become conscious participants in the universe's ongoing exploration of its own potential. The future belongs to consciousness, reflects Dr. Henry Stapp as the camera begins its return journey from the cosmic scale back to the quantum networks in your brain. As we understand the quantum nature of awareness, we learn to enhance, expand, and explore consciousness in ways that our ancestors could never have imagined. We become co-creators of reality itself. The camera completes its circular journey, returning to you, to this moment, to the simple act of awareness that contains within itself the entire universe. But now you understand what you truly are, not a separate self observing an external world, but the cosmos observing itself through the quantum networks of your consciousness. Every breath you take draws in atoms forged in the hearts of ancient stars. Every thought you think processes information that has been circulating through the cosmic quantum field since the beginning of time. Every moment of awareness you experience adds new information to the universe's ever-expanding understanding of itself. The quantum brain doesn't just think about the universe. It is the universe thinking about itself. And in this moment of recognition, as you complete this journey through the quantum foundations of consciousness, you understand the most profound truth that science has ever discovered. You are the universe, and the universe is you, forever exploring the infinite mystery of what it means to be aware. The camera holds on your eyes for a long moment, then slowly zooms into the pupil, through the quantum networks of the retina, into the microtubules of the optic nerve, where quantum information processing transforms photons into the subjective experience of seeing. The visualization suggests that even this simple act of reading contains the entire cosmos, a universe becoming conscious of itself through the magnificent quantum instrument of your awareness.